And finally we come to awk. Awk is probably the granddaddy of all filters. The text processing that you can perform with awk covers, well, just about any text processing you could ever want to do. Awk actually stands for Aho, Weinberger and Kernighan, who are the three gentlemen that created it. It's not just a text processing tool, it's also a full-on programming language in its own right. It supports if statements, loops, functions, and just about every other major feature of a procedural programming language. It's an extremely powerful filter because of this, but it is also consequently probably the most difficult of all filters to master. I was once charged with a development project in awk, and the final program that I came up with was over 3,000 lines long. Now, I'm not going to go into the depth of awk required for such programs. I'm going to just give you the basics that you'd use in a conventional shell script. If I was to go into awk in its own right, we'd probably have another training course, another CD if you like. So its usage is fairly similar to sed as follows. You specify an action and then you specify the files that you want to perform the action on. As with sed and all the other filters, the files parameters are optional, and if you don't specify them, it takes its input from standard input, the keyboard, or another program. Differently to sed, however, the action that you specify is actually specified a little differently. It's a sequence of statements enclosed in curly brackets or parentheses. Each of them is separated from the next by a semicolon. For example, you take the who program and pipe it to awk, and notice that there is one parameter after awk, which is the one action that we want to perform. The action is enclosed in braces, curly brackets, and all of that is enclosed in single quotes. Now, because it's enclosed in single quotes, things like the $1 and the $2 that you can see there are treated as special characters by the awk program. They're not treated as special characters by the shell. So similarly to sed, you should enclose all awk actions inside single quotes. So in order to understand what's happening here, we're obviously going to be printing something out. We're probably going to be printing out the words is on terminal at some point. But we've got this $1 and $2 and the commas to worry about. So in order to understand exactly what's going on here, why don't we have a look at the output of the who program in some more depth. So if we run who, we find that it consists of a username, followed by some spaces or tabs, followed by a terminal, followed by some spaces or tabs, followed by a month, then a day, and then a time. Now, I was being pretty pedantic, mentioning that things were being separated by spaces and tabs, but that is actually significant, especially when it comes to awk. So this is how we treat each one of these lines. Each one of these lines can be said to be broken up into a series of tokens, and each token is separated from the next by either a space or a tab or a series of spaces and or tabs. And so it's fair to say that on each line we have 5 tokens. One is the username, then the terminal, then the month, the day, and finally the time. Now these 5 tokens are actually numbered by awk. They're not numbered at the moment because we haven't involved awk in this equation yet. We've just used the who program, but if awk was to get involved, each line would be said to consist of $1, $2, $3, $4, and $5. So $2, of course, would be, in this case, the terminal, and $3 would be the month, and so on. So if we were to type in the command line that we just had a look at just a moment ago, and there it is, then we run that, and we get the output displayed slightly differently. $1, as you recall, was the username, and $2 was the terminal. In this case, for example, PTS38, PTS48, and so on. So the command line itself involves a print statement. So what print does is it takes a series of parameters. In this case, there are 3 parameters, and they're separated by commas, $1, and then the next one is just a text string, is on terminal, and then the third parameter is $2. And what print does is it prints out on the screen each of those 3 parameters separated by spaces. So it prints out $1 first, in other words the username, followed by a space, followed by the 3 words is on terminal, followed by another space, followed by the $2, which in this case will be the terminal. I hope you're beginning to see the pattern of how awk works. So to summarize that business about tokens, $1, $2, and $3, and so on are the tokens from each line of input. And by default, tokens are separated by spaces and or tabs. Now, it's actually possible, using the -F option to awk, to specify the characters used to separate tokens. For example, here is another awk line, and this time I'm using the -F colon. Now that designates the colon as being the token separator instead of spaces and tabs. If you think back to our course project, we're actually using the colon there to separate one field from the next. That's what the F stands for field separator. And if you've ever had a look in the file etc. password, which is what we're dealing with here on this line, you'll find that it is also separated from one token to the next by a colon. Let's have a look at that. Here is etc. password, and as you can see, there's a bunch of fields on each line. There's the username, and then that little X is supposed to represent where the password goes, so that's 2. Then the user number and the group, that's 4. Then their name, 5. Then their login directory, 6. And finally their shell, 7. So there are 7 different parameters on the line, and each is separated from the next by a colon. So if we wanted to use awk to tokenize each line of the /etc/password file, we'd need to use the -F colon field separator is colon option to break it up into the various tokens. So once it's broken up that way, we can obviously print out $1, which would be the username, and then a space, and then home colon, and then a $6, which $6, as I recall, is the user's home directory. So let's have a look at that working in action. Here is a little file that I'll actually put on the CD for you called parse password, which parses the password file in /etc. And it's a shell script, so let's run it. Run it like that, and as you can see, there's quite a lot of output because we have a very big /etc/password file. Now I pressed Control-C there to stop it scrolling all day, but you can see that it's actually working. For each one, R. Ryan's home dir is /home3/R. Ryan, and so on. And that's all made possible by way of the field separator being specified as a colon. Now it's actually possible to perform different actions on lines that match certain patterns. In other words, you can have one collection of actions for lines that match one pattern, and you can have another collection of lines of actions for lines that match a different pattern. For example, for all the lines that match Australia, that have got the word Australia somewhere in the line, then we just want to print out the very first parameter on that line, whatever that happens to be. If you wanted to specify a different action for a different pattern, then after the closing brace, after the closing curly bracket, you'd put a space and then another pattern, like /England/ and then another set of actions enclosed in braces, and so on. Now these command lines can actually get quite long, but that's perfectly normal, and I'll show you in a moment how to create actual standalone awk scripts that really don't have a command line as such. Anyway, we'll have a look at that in a moment. But before we do that, I'll mention that it's actually possible in awk to perform arithmetic, and you might do it like this. We'd assume here that database is a text-based database that contains at least 5 parameters on each line, and maybe the 3rd, 4th, and 5th parameters are numeric. So you could add the 3rd and the 4th one together and divide the result by the 5th one on each line, and that would print out the appropriate answer. So anyway, getting back to very complex awk scripts, if you want to do many actions at once, then what you might do is put them in a separate file. awk-f script file, input file. It's very similar to sed. In fact, it's almost identical to the sed technique. Now that script file that you specify does not have to be executable, and it doesn't have to have an interpreter definition on the very first line. The interpreter definition, of course, being that #! Script file in this case is just a straight text file. It is, of course, possible to create a script file that's standalone. It doesn't need to be called with the awk-f option on the command line. I'll show that to you. It's possible to create standalone awk scripts, and this is an example of a standalone awk script. You start with the script interpreter. On the very first line, you specify that this entire script must be interpreted by the awk program with the -f option. and that is of course the password option that we had a look at just a moment ago. So I'll actually show that to you. So here is a standalone awk script. Now this script has actually been made executable, and I've got a script interpreter as the very first line, which will cause this script, this program, when I run it, to actually be interpreted by awk. Now the last part of the script, which is the brace and then the printf line, I haven't shown you printf yet, but I'll show that to you shortly. That's the part of the script that you've probably seen already. All I've done is I've put each curly bracket, each brace on a separate line, and I've put the print line on a line by itself. What you haven't seen is another set of braces up the top there, following the word begin. And everything inside that first set of braces is a series of statements that is run before the input is even open for processing. So in here you can do all your initialization. You can print out any headings that you want to print out. You can set up a bunch of variables and so on. And similarly, if you needed to do some processing at the end, after the input had been processed, you could create another set of curly brackets following the word end in capitals. So the only thing that we're actually doing in the beginning part is we're specifying that the field separator is a colon. That's exactly equivalent to doing a -F colon option on the command line. Okay, so let's quit out of this so we can actually run it and test it. And we quit. Now let's run it. It was, I believe, called password2.awk. I've just put the .awk extension on the end only to distinguish it from the other one, to show that this is an actual standalone script, and we'll process the file, etc. password. And of course it's working as we would expect. So naturally that awk script that I wrote, which ended up being about, 10 lines long, could easily grow to as many lines as you like. Don't forget to end each line with a semicolon if there's more than one statement between a set of curly brackets. So here is an example, of course. If I took those 2 lines and put them in a file called myawkscript and made it executable, then I could run it in the following way. Now here's that printf facility that I mentioned just a moment ago. It's actually a slightly more powerful print facility than actually the word print. It's called printf. The F stands for formatting, and it's very similar to the printf function used in C and C++. It looks like this. Now actually that entire printf statement that you see there should be enclosed in curly brackets, but we'll just pretend that that is for the moment. I don't really want to go into the ins and outs of printf because it would take quite a long time to explain, probably more than that particular topic warrants at the moment. Suffice it to say that there's plenty of documentation about it in the manual pages and also on the internet if you look hard enough. What I will say is that it is possible in this way to specify exactly how many characters wide the printing of each field should be. So here I've got $1 and $6 both being printed out, and that's the %-12s and the %-20s, which specifies that $1 will be printed out in a width of exactly 12 characters. So no matter how many characters there are in each $1, it will be printed out and padded on the right-hand side with spaces to a width of 12 characters. And $6 will be printed out in a width of 20 characters. So using this technique, it's actually possible to get output beautifully aligned under headings and so forth. Let me show you what I mean. I'll just modify that script I just showed you. So here it is, slightly rewritten, that awk script that I showed you just a moment ago. I've put in the %-12s and %-20s, so $1 will be printed in a width of 12 and $6 will be printed in a width of 20. Now for that to be meaningful, I've actually created little headings here, username and directory. Notice that username is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 characters wide, and directory is 20 characters wide if you go all the way to there. And because these 2 lines of code have been created inside the begin set of statement block, they will be printed out once and once only at the beginning of the program, whereas this line here will be printed out once for each line of input. So let's see that in action. We'll run this script % and we'll feed it one parameter, which is etc. password, and we better pipe the results to more so we can see the heading. And there you go, username and directory, and it's all nicely formatted as you can see. That's the way you achieve that sort of output using awk. Also note that using printf you actually have to specify that you want to have a new line at the end of the output if you do. And new lines are specified just as they are in C and C++ using the \n. If you want a new line followed by a blank line, then obviously put 2 \n's. Okay, so that's really all I want to go into on awk. You can actually buy entire books on awk, so there's no end of learning that you can do just on that program. It's a very powerful, as you can see, text processing language, but I've shown you the basics that you need to get started with simple shell programming. And that actually brings us to the end of the chapter on filters, so let's now have a look at some exercises involving those.